Hello everyone. So I see the people just trying to connect. Let me share my screen. Okay. So let's start this amazing webinar in robotics in healthcare. Wait a second. Well, good morning everyone, ladies and gentlemen. Welcome to this Robotic in Health webinar. I am Marta Perez, consultant and working in integrated health solutions in Medtronic, Spain. I am the leader of this amazing ecosystem and open innovation in ODIN project, and I will be your host during today. Well, as you can see here, we have an exciting lineup of speakers who will be sharing their expertise on the robotics. Let me introduce our speakers today. We have Gastone Ciuti, Associate Professor of Bioengineering in the Scuola Superiore Sant'Anna. He's our robotic manager in Odin. Oreste Ricardo Natale, he's the CEO of Mosaico and one of our open call winners. We have also Ricardo Tornese, CEO and founder of Tactile Robots. And we have Luigi Tagliavini, PhD from the Politecnico di Torino. Each of our speakers brings a wealth of knowledge and experience to the table, and I'm certain you will find their insights invaluable. Before we dive into the different presentations they have prepared, let me briefly outline the agenda for today. This webinar aims to explore the potential of mobile robotics in revolutioning healthcare delivery. All of you will have the opportunity to embark on a journey through the world of mobile robotics by listening to the experts in this domain. Each panelist will have 10 minutes for each presentation, and at the end of all presentations, we will have 15 minutes for question and answers. So please feel free to submit your questions in the chat box. Now, without further delay, let's begin with our first speaker. Gastone, the virtual floor is yours. You are on mute, Gastone.
Thank you very much, Marta. So thank you very much for inviting me. It's my pleasure. I would like to thank you and as well as Sergio for organizing this great event. I share my screen and start my 10 minutes presentation, hoping that it will be full of questions at the end, because for sure the goal is to let's say solve possible, let's say, doubts and question the audience has. So as Marta introduced me, I'm an associate professor of bioengineering. I'm also working in a company that I founded. So I work in research and industry as well. So I like to start just a few seconds to say when we started talking about robotics. This is a milestone of robotics in 1954, one of the first patents on a robot, programmed article transfer. And who is the responsible of this patent? That person you see here on the right, George Devil. George Devil founded together with Joseph Engelberger in 1962 the Unimation Inc. Is it a great company? Yes, it's the first company on robotics, and the company is responsible of the illuminated robots yeah, these kind of robots, they were the first robot introduced in factory plants, but then these robots, as you can see here, the Puma robot, for example, was used also in different other activities, such as also first medical robotics attempts. This is just for giving a short introduction and provide a view of when we started really talking about robotics, because yeah, it's around 60 years ago. And the topic of this call today is not on anthropomorphic robots. I will focus on social and service robots. And in particular, I will provide solution for delivering robots working into hospital environments in order to share to shape the future of the hospital. But let me make a step back again. This is the same person I presented you before, Joseph Engelberger, that in 1984 founded another company. It's called Transitions Research Corporation. And yeah, you see on the background some mobile robots. You see, let's say, 4 mobile robots on the background of these slides, and this is the helpmate robot. Okay, these robots are on the floor of company I mentioned you before, and this is a picture of 1993. So why I'm saying that? Because I like very much to know about history, but I like history. It's important to understand which are the reasons why today I don't see that technology consolidated as I would like to see. So the question I would like to discuss with you, to solve with you, or starting, let's say, discussing is why 30 actually years ago, almost 30 years ago, we have these great robots, or however, robots that have functionalities for delivering let's say, consumables, for delivering items in general in hospitals. So for logistic aspects and how to, let's say, really improve them and how to solve, let's say, the open issues that started with these robots in the past. So discussing between, let's say, the consortium of ODIN and discussing with other colleagues, we decided to create and then to test in the great piloting area hospitals of the consortium a new robot for logistics that is not a robot that is full of technologies. It's a robot that just started by a smart idea and by the needs of practitioners and of the hospital management systems. This is, let me just say from the beginning, that this is a robot integrated within the wide infrastructure, okay, digital infrastructure of the ODIN European project. So this is an example of a robotic satellite that is connected to a complex digital architecture that is the aim of the ODIN European project. So what are the features of this robot that are different from the ones available today on the markets or in research? We decided to create, let's say, a smart component in a smart component. So the robot itself is the system that is delivering the what we call smart rack, and the smart rack is delivering the smart boxes. So it's a system that is transported by a mobile robot. And this infrastructure is generalized to be compatible with different mobile robots. To better explain the feature of this system, I will talk on a video that it will take a few minutes of my presentation. And what you see here is the use of the hotspot robot. Yes, this is the name of the robot, into the a real, let's say, an environment that simulated in a realistic way the hospital scenario. So as you can see here, this is just a tablet stitched on our robot, but this is the front end for the connection with the ODIN infrastructure. So what the doctors is doing now on our system is to, in that case, unlocking the box in order to have access to a secure environment. So now there's not a robot. The robot will come. What is doing now that person is use a smart robotized box, okay, for tracking, identifying, and so loading different consumables. So we are just putting consumables that are tracked by our magic box, okay? So the boxes that we call smart boxes are part of a smart rack. Why a smart rack? Because it's the rack that is powering and enabling the access to the different boxes. Here you see an example of adding consumables for tracking and transporting consumables in the different wards of the hospital. So for planning, okay, a consumable in the right place, in the right time. But each box can have a different functionality. Now the operator call the robot. So the robot is one robot for different racks, one robot for different, let's say, smart racks. Why? Because the real cost now is on the mobile robot. And I'm sure that a robot is not working 24 hours per day, 7 days per week with the same robot. So what we did as the smart idea I said before is to have several, let's say, low-cost smart racks and boxes that you can change as you like, and then maybe a few mobile robots for managing the different transportations. That's the point, okay? Because we want also to increase the potential impact by reducing the barriers at the entrance, no? So, and the cost is one of. But not only the cost, because when a director see that the robot she purchased is not used, is not happy, or she's not happy. So we want to say, do you need one rack? Yes, take one rack, and then now take one robot. If you need more racks, if you need more boxes, this is what you will, let's say, purchase, creating a proper strategy, also considering fleet management strategies to use less robot for more, let's say, containers, for more boxes, for more racks. The robot is for sure provided with collision avoidance. So the robot is not going against robots, it's not going against humans, is moving, replicating, let's say, also the behavior and speed of practitioners. So we are also working on creating a proper, let's say, social aura around the robot to make that compliant with an hospital environment. So what you see now is that the robot was programmed to reach another place autonomously. When the robots reach the final place, another practitioner could go there, or maybe it's already there, access the system, unlock the box, remove the consumable, or use the boxes as she prefers. Okay, so this is a description of a new conceptual design and a new way for, let's say, using robots at the proper use of a robot. So without, let's say, having robots because it's just cool to have, but having the less numbers of robotic system in a smart integrated architecture, also considering cost and the, let's say, encumbrances or other aspects that the robots may have to allow and improve compatibility with hospital. What you have seen in the video is that the robot goes for another mission, and the practitioner can just clicking on smart box, opening the smart box, remove consumables, add new consumables. Everything is tracked by our digital architecture. The smart box can be used by themselves. So you can use as a box for the last mile delivery, because sometimes a robot cannot enter rooms. So you take a box that is robotized. You move where you want, so you can transport as you prefer. Then I go on just for making that, and then you can move the racks as having a mobile, let's say, wardrobe to to without, let's say, reducing, let's say, improving, let's say, its usability. So finally, which are the feature in fields? So we created a robot with high modularity, so you can move the rack as you prefer. You can add different boxes with different functionalities. You can prepare boxes the day before and then having everything ready for the delivery. We have interaction strategies, so LEDs and sounds for making the robots properly interacting with users. We have algorithms from object recognition, so making these smart boxes smart enough to recognize consumable in an easy and fast way. And then we created Dockers in order to make the mobile robots attach with the rack, powering the rack, powering the box, and delivering the mission. So I conclude. I hope that I was on time, Marta, and for sure and I hope that it was interesting for the audience and for colleagues. Thank you very much.
Thank you. Thank you so much, Gastone. Indeed, very, very interesting, amazing hotspot presentation. And I'm pretty sure that the audience have really enjoyed a lot. Thank you so much, Gastone. Now, I give the virtual floor to Oreste Ricardo Natale, CEO from Mosaico. He won our open call, and I'm pretty sure he will bring a lot of insights about mobile robotics. Now.
Thank you very much, Marta, for inviting me, and thank you very much for your introduction. Let me share my screen. Okay. Okay. So again, thank you very much for joining us today. I will talk now about the project in which we are working within the ODIN framework. Our application is called Freki. As I will tell you in a moment, it involves the use of a mobile robot that actually resembles a dog. And Freki actually is one, in the mythology, is one of the two hounds of Odin. That's why we choose that name. Well, we will talk about what are our motivation, our goals, where we are now along the project, and what is the road ahead. The idea is that we would like to demonstrate the use of a mobile robot to help to reduce the incidence of healthcare acquired infection, which is actually recognized as a global public health problem. Because, well, of every 100 patients, between 7 and 15 will contract this kind of infections, and among 1 every 10 actually will lose his life because of this huge issue. One of the recognized means to reduce the impact of healthcare acquired infection is to perform the analysis of the samples taken by swabbing the surfaces of an healthcare facility, looking actually for pathogens, which are, of course, responsible of the infection. As I said, our idea is to use a mobile robot like this one to walk around the healthcare facility, around the hospital, taking the samples that need to be analyzed, to search for pathogens. So we have chosen this platform. The platform is the robot called Spotter made by Boston Dynamics, equipped with the robotic arm, because the idea is to equip the back of the robots, the shoulders of the robots, with a swab rack, which contains actually the swabs that the robot uses to perform to take samples by swabbing the surfaces. The project started last February, and it will last 1 year, so ending February 2024. What we have done so far, so we have actually successfully tested an autonomous swab mission in our lab in couple of cases, let's say the simplest one where there is no obstacles, and also when there are pop-up obstacles along the mission path. That means that we have, using this kind of equipment, we are able to perform the mission, even if along the path that the robot finds obstacles that are not known in advance. What happens is that once the area has been mapped, the robot tries to find a suitable alternative path if the nominal path is obstructed by obstacles, and if constraints are matched, the robot actually walks around the obstacles and moves to the sampling and proceeds along the path to reach its destination, the place where it has to take the samples. The robot is a good, an amazing technology, because it has the abilities to go wherever a human can go. Can climb the stairs, he can open the door, basically inside or outside of buildings. Also, we are now at the step where we are, as I will show after that, we are designing, optimizing the swab rack, which is here on the back of the robot, so to hold as many swab as possible. So now I would like to show a video. So actually, what I would like to do is to stop this. Okay, and I will try to show the video now. Okay. I wonder if you can see the video, maybe not. No, let me try to show, share it again. No. Okay, so what I do now, I will just put here into the chat the link to the video, so that everyone can, click on the link and see the video. Let me just try one last time. No, it doesn't come up. Okay, so it's pretty strange right at the moment, but if you click on the link, please, you can actually, the link that I placed into the chat, you can actually, hopefully, but I'm not very happy about that. Let me see if I can share the whole screen. Okay, maybe sharing the whole screen. Sharing the whole string should, can you see the video now?
No, not really.
Let me
No,
make the very last attempt, then we move on.
Yes, please.
The video doesn't come up. Okay, so please have a look at the link that I've shown in the chat, so that it can even be available after the the presentation. As you can see in the video that is shown, if you access the link, because the presentation doesn't show up at the moment, you can actually see the robot that is performing an autonomous swab mission. So basically, the robot proceed along the path to reach its destination, and it avoids actually the obstacles that it finds along the way, if there is any. And once the robot reaches the destination, it actually performs the swab operation by using the robotic arm, which is equipped on the top of the robot. The idea here, as you can see in the video, this is one of the, so it's an early stage, a prototype of an application at the early stage where there is just one swab equipped on the top. The idea, as I will show you in a minute, is to equip the robot with a swab rack which can hold as many as possible, which should be in this first iteration with the maximum number of 12. The idea is that the robot proceeds along the path and performs all the swab in the designated area, and then walks back to the lab to check, so to have those samples analyzed to look for pathogens. Again, if the robot finds obstacles along the way, it tries to find an alternative path. If constraints are physical constraints not matched, the robot find the alternative paths. Otherwise, it just stays still, notifying for the problem and waiting for the obstacles to move away. Let me go back to the presentation. Hopefully, it will go back to the presentation. And I think that you cannot actually, something happened, because I see that I'm sharing the screen, but nothing is shown. Is that correct, Marta?
I can see your presentation, but not in presentation mode. I don't know.
Okay, let me start like this. Okay, now should be in presentation mode.
Yeah.
Okay, so one of the last things that I would like to show is that this is the swab rack that we are designing now, which should be able to hold between 6 or 12, it depends. Actually, we have to test it. Same. So the idea is to make a mission as efficient as possible, putting on the back of the robot as many swab as possible, and should be between 6 and 12. I didn't make it, we didn't make it to have it ready for today's presentation, but that's the design. And next week, because it should be, this should be tested. And last things that I would like to talk about is the road ahead. So as you may have seen in the video, at the link that I put into the chat, the robot takes samples of the floor. The floor is a surface where pathogens can be found, but we need to look for more specific surfaces inside the healthcare facilities, which are smaller and difficult to take the samples on. And these are door handles, handrails, or bed nightstands, or basically any surfaces where people, healthcare workers or patients or family of the patients can actually touch. And those are the places where most probably pathogens can be found. However, this cannot be done, let's say, technically speaking, open loop, as we have done on the floor, but we must detect inside the area those small surfaces. And the idea, of course, is to take advantage of artificial vision or to detect those more surfaces and plan the swab missions on the fly once the area have been detected. We are already working on that, and hopefully this should be ready by the end of the project, and we will test all these things all'Università Campus Biomedico in Rome by the end of the project, which will be around in January 2024. That's it. Many thanks.
Thank you so much for this amazing presentation as well, Ricardo. I'm pretty sure people will raise different questions at the end of all the presentations. Now we jump to the presentation of Ricardo Tornese. He is the CEO and founder of Tactile Robotics. Thank you, Ricardo, for being here today, and the floor is yours.
Hi, everybody. Can you hear me?
Yeah.
Okay. Thank you very much for having invited me. I'm Riccardo Tornese. I'm the founder of Tactile Robots. We do delivery robots with the sense of touch. This is our range of products at the moment. So we have a generic base with differential drive, on top of which we have a body that is designed for deliveries in restaurants. But the base is a general purpose base, so it can be used for several applications. And we are also offering custom designs. So a design that based on what you see on the right, but can be customized in terms of shape. So the width, the length, the height, in order to fit with the specific needs of each possible application. We have experience in designing and programming mobile robots. So the electronics, the mechanics, and the software at the different stacks, also the user interface. Let's take a look a bit at our current product. It's a delivery robot for hotels and restaurants with a screen for the user interaction. And it is capable of moving safely thanks to 3D cameras and a LiDAR. It has no blind spots, and it is capable of calibrating the position of the sensors in an autonomous way. It has a very special feature that is the characteristic of our robots, which is the fact of having the sense of touch. In particular, in the robot, you can find in the bottom a tactile sensor, which is a kind of smart soft bumper, which can feel the pressure and identify also the point of contact. We have patented, in particular, a way to interact with the robot thanks to this technology, which is an example is the image you can see on the left with a preview prototype for room delivery in hotels. But we are finding out new applications of our technology. For instance, one is to enter into the kitchen by passing through the swinging doors. This is something that can normally not be done by other robots, except if you install a specific automation system. So you need to put a motor, a sensor, and the kind of a way of communicating. So it's quite complicated and expensive. So actually, deliveries into the kitchen are not even done. So the use case of clearing tables is not really exploited up to now by the existing robots. On the contrary, thanks to our technology, the robot can get in contact with the door without scratches because the bumper is soft and covered by a textile that is made for resisting to the contact. And you can also feel the force applied, so that if there is something or somebody behind the door, the robot stops and lets and gets compliant, so that the person can safely move the robot away. This is one use case for this robot in the Rega field, which is deliveries to the table. So the staff fills in the robot with everything that should be delivered, sets the destination, and the robot goes to the right table. Then the client can take food by himself, or is the waiter that can serve people. And then the robot goes back to the base. There are many variations of this. The robot can take different paths. or it can just stay. So there are a lot of ways to use the robot. Another one is to use it for clearing. So in that case, there are two ways that you have, two use cases that we have identified. One is that the waiter calls the robot to a specific table so it can clear the table, and then the robot goes to the kitchen where it is cleared by somebody, by the kitchen staff. Or the robot can go on a path continuously and then go to the kitchen and so on, so that the stuff which stays in the kitchen can fill in the robot, and then the stuff in the room at the tables can fill in the robot, and then in the kitchen the staff can clean it. But we are moving to a next step where we combine our new design of robot, which has a bigger screen and the lower costs, with the other technologies such as artificial intelligence, speech synthesis and recognition, and even payments for some specific use cases, so that we can have a robot that is a delivery robot, but also a social robot. So we can expand much more the use cases of this robot in the Rega field. Can be, for instance, taking payments and orders. But this is the most interesting point from my opinion. All these technologies can potentially also have applications in the hospitals. I leave this page blank because actually I would like to ideally to have some feedback from you about which are the possible applications of this kind of technologies into the hospitals. From my experience, one could be delivery of meals, for instance, mainly outside of the meal time. So when the patients need something when it's not lunchtime or dinner or breakfast, it may be complicated to go take food into the kitchen or the warehouse and bring it to the patient because the distances are very big, and an automated solution that could help a lot. Or the delivery of drugs, medicines, and or even heavy equipment for the staff, to helping the staff not making effort. Also, in this case, the tactile technology can be significant plus, because when the environment is very narrow and crowded, having the possibility to nudge a robot with a light touch or to stop it and make the people pass can be probably a big advantage. So I'm very open to answer to your questions and also to get feedbacks and maybe having a follow-up. Thank you very much.
Thank you so much, Ricardo, also for this presentation. We are really navigating through the different mobile robots and different applications, and I'm pretty sure the next and the last one also will bring very insights. So, Luigi, the floor is yours.
Okay, thank you very much for the invitation and for the presentation, Marta. My name is Luigi Tagliavini. I'm a PhD student at Politecnico di Torino, Italy. Today I would like to present you this project that we are developing that is about mobile service robot for hospital environment. As you will see, our project is about research, and so I'm sorry for the poor quality of the aesthetics of our system, but I hope this will add a useful case for the discussion later. Okay. So a few words about our research group. The laboratories heads of our research team are Professor Quaglia and Professor Visconte. Andrea Botta is a researcher at Politecnico, while Lorenzo, Mohammed, and Giovanni are colleagues of mine, and they are PhD students too. A little bit of context before starting with the solution we are developing. We decided to start this journey because of two main reasons. The first one is population aging is strongly affecting our society, and among all the problems, improved healthcare system are needed. On the other hand, we are facing a huge shortage of healthcare workers that is estimated around 15 million around the world. So in this context, we think that automatized caregiving systems can help health workers and the patients, both in hospitals and in domestic care. Here we would like to share with you a brief video of our robot that is called Pakitop. I hope the video is not going to be too laggy. The robot has a compact size to navigate within an indoor environment. It's provided with an omnidirectional base. And on this base platform, we installed a collaborative robotic arm to interact with the surrounding environment. Moreover, specific sensors and tools can be mounted on the robot based on a specific application we want to address. Here, I want to share with you a more detailed description of the component of the robot. As I said before, the main peculiarities of this robot is the fact that the base platform can move in any direction in the plane of motion. And we achieve this omnidirectional mobility using conventional wheels to avoid the problems that are related to other types of wheel, like mechanon wheels and omni wheels, that they are strongly affected by ground unevenness and small steps. To achieve this omnidirectional mobility, we used two motor wheels that are mounted on two vertical steering axes. By controlling these actuators, we can implement different mode configuration for driving the robot. And with this kind of locomotion system, we can achieve a complex movement like the ones that you can see in these animations. So in particular, today, I would like to talk about a project that we developed in collaboration with the nonprofit organization Fondazione DOT and the Molinette staff at the hospital here in Turin. The project goal is to test the effectiveness of a robotic assistant like Pakitop in an hospital environment. The goal is to lower the job pressure on the healthcare staff, while at the same time improving the data collection of patients' body parameters. Together with our partners, we identified two applications for the Pakitop robot. The first one uses the robot as an assistant in the blood bank of the hospital, while the second one deals with the transportation of materials around the hospital ward. We decided to focus on the first one since we wanted to test also the capability of the robot at interacting with the patients. So before customizing the robot for this specific application, we decided to focus on what are the main problems that we can find in the blood bank of the hospital. The first one is the fact that multiple matching checks between blood bags and patients are needed to ensure safety. And this is an easy task that can be automatized. So this is the first task we want to address. The second one is more related to the Molinette Hospital in Turin, where the blood bank is composed of different rooms that are separated between one another. And because usually the staff is not enough to cover all the rooms, they set up the transfusional seats and then they wait in one room that is the main one. So we want to include patient remote monitoring for this reason. And finally, we want to include also a basic level of a patient's body parameter monitoring, for example, body temperature. But unfortunately, we didn't manage to acquire the sensors before the test. So in the first test, there was no body parameters acquisition, but in the future, we would like to implement this feature. So we imagine that the robot is a moving agent that moves from one transfusional seat and the other, and interacts with the patients at each seat. Here there is a brief video of the test that we performed at the hospital. First, the robot detects the tag of the blood bag. Then it extracts the human-machine interface that is developed on a tablet. And it positions the tablet dynamically in a way that is comfortable for the user to work with. Then the patient is identified and he can interact with the machine using the tablet. Then the robot retracts the human-machine interface and moves to the next station. This is performed all autonomously for now, even if we need to improve the 3D map for obstacle avoidance using the robotic arm. So after all the tasks, all the stations are completed, the platform returns to its charging station. While working on this project at the hospital, we decided to investigate a little bit more alternatives interfaces to drive the robotic platform. Since ideally no training should be needed to drive the robotic system. To do this, we implemented a force control of the robot. In this this video, you can see Lorenzo, my colleague, that is applying small forces on the tip of the end effector of the robot. And by measuring the currents of the motors of the robotic arm and a particular algorithm, we are able to estimate the forces that the user is applying on the robotic arm. And these forces are then transformed into velocity commands for the base platform. In this way, we wanted to achieve a simple way to drive the platform around, save the position of the transfusional seat, and plan the entire task. So this was my presentation. I hope this was interesting for you. For future application, we are looking forward to other fields of application for this robot. And a thing that I want to underline is the fact that to fully exploit all the functionality of this kind of robot, a complete integration between the robotic system and the informatic infrastructure of the hospital is fundamental. And I think that ODIN is moving into that direction. So happy to be part of this webinar. If you have any question, I'm happy to answer.
Thank you so much, Luigi, for this great presentation. Now we have well, more knowledge about what Paquito can do. So thank you so much for this. Now, as you just mentioned, we open the floor to the audience for any questions that they may have. So please feel free to raise your question through the question and answer channel. Don't be shy. If not, well, I have prepared some questions for the audience that we can share. So, for example, for Gastone, maybe you can answer this question. What role do data analytics and artificial intelligence play in maximizing the potential of robotics in healthcare? And how can these technologies be leveraged for improved patients' outcomes?
Thank you very much, Marta. And the question is very important. I hope that the answer will cover the importance of the question. But for simplifying, what is a robot without control? What is a robot without data? What is a robot without intelligence? So it's pieces of methods. No, so I think that is absolutely important, and the real difference that we can do is to provide let me call human intelligence in a sense instead of calling artificial intelligence to the robots. Okay, I say human intelligence because I don't want to consider a robot acting as a human. This is not what I'm saying, and I don't think it's effective. But compliant, yes. Compliant with the habits, compliant with the spaces, compliant because we cannot completely change now everything around to put there a robot. We have to put the robot there based on the environments that today is consolidated, and then step by step, let's say, working together and improving together. No, because now the robotics domain and artificial intelligence domain is moving very, 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 very fast. Okay, and it's moving faster than the modification you can expect in the infrastructures and other, let's say, physical scenarios. No, so what I'm saying is that let's be compliant and not invasive, demonstrating that the robots can be a benefit, but trying to fit the robots in the current, let's say, scenarios. And that's possible only if a robot is intelligent. So if can use data, can tune and adapt to the real-time needs, and so let's say data mining or in general using different kind of data and using the robot as a simple and effectors is the key for evolving, okay, really that the day-to-day scenarios in the hospital and in the houses and not only. And for sure, going towards the patient, let's say, clinical improvements, but also for the practitioners, because, let me say, a patient is there for a clear motivation, health. Practitioner is there every day for, let's say, as a work for supporting patients. And I think that you have to think about patients as well as think about practitioners, because sometimes surgeons, but not only, they work in very complex environments. So robots can really support, but not a simple end effector. So let me cite a guru of robotics, that is Professor Russell Taylor from Johns Hopkins University, that defined CAS, computer-assisted surgery, in general, computer-integrated surgery. A robot is not just a simple robot, or in general, a computer-integrated scenario is not just a simple robot. It's a robot integrated into an infrastructure that is a digital infrastructure, and for sure, where sensors, intraoperative, postoperative, preoperative, or in general, data coming from patients in unstructured environments is the real way for making a robot compliant with the environment itself. So, I stopped my answer because I could talk for 1 hour, but tell me, Marta, if I explain at least my point in pills.
Yeah, indeed, Gastone. Thank you very much for your answer to this question. And indeed, the robots are now. We are looking to the future, and I'm pretty sure all the robots are going to be very useful in the healthcare system, and we are going to really improve the patient and also the clinicians in this field. So yeah. Next question. How do considerations of cost, effectiveness, and return on investment factor into the decisions-making process for adopting robotics in healthcare, and what strategies can be employed to demonstrate long-term value? Maybe Ricardo Tornese can answer to this question.
Marta, yes, thank you very much. This is actually a question that is very important in understanding why a technology can be of use in this field. And this kind of robotic applications can have really different impacts according to the use cases that they are employed to. So for what concerns deliveries, which is what we are more focused on, actually the positive impact is the fact that the staff can spend less time in going around into the hospital. And in the hospitals, the distances are very big. There are elevators to take. So it takes really a lot of time to perform just one delivery. So there can be really big savings in terms of time and in terms of effort. This means that the same person can spend more time in added value activities. So taking care of patients rather than doing logistic stuff. And this is something that applies to several use cases. You can deliver food or medicines or equipment. It's always valid. So the decision-making process, from my point of view, should take into account how much the robot can cost and how much reduction of cost they can bring to. And normally in this field, it's really worth making this kind of investment. Of course, pilots can be a very good way to start testing these solutions and demonstrating which is the long-term value that this kind of technologies can bring to the hospital.
Yeah, indeed, Ricardo. So, for example, in ODIN, we are testing our robots in five different pilots. Now we have added 2 more, so we have 7 pilots in order to assess the technology. So this is really an important decision-making factor. Yeah. So next question, what are some successful case studies, for example, of healthcare organizations that have effectively implemented robotics, and what lessons can be learned from their experience? I guess Luigi can answer this question.
Yes, I think that the most explored case studies in this field are remote presence, in particular for intensive care units. For example, Tommy, the robot Tommy, has been used in an hospital in Varese during COVID-19 pandemic. And also other types of robots have been used in this sense. And so I think that there are a lot of use cases, for example, sanitation of rooms, transportations, a lot of prototypes, a lot of pilots. And I think that as a research community, we need to keep pushing the technology in this sense. But still, for the real implementation of this kind of system in the hospital environment, I think that every pilot in this sense is limited by the informatic infrastructure of hospitals in general. So I think that all the informatic infrastructure need to be redesigned as a whole, has to be integrated with a robotic system, with wearable sensors, and with all the new technology that we want to implement in healthcare organization. So I think that is the thing we should learn from the fact that it's important to improve the technology, but for real effective application, we need to focus on those stuff, because it's very common to see hospitals lacking of essential technology, like from computers, from printers, from a very well-structured database that can be accessed in a different part of the organization. So I think that that is for sure something that we need to focus on in the future.
Yeah, for sure, Luigi. Thank you so much for answering this question, and also for the audience, you can check our main website, ODIN Smart Hospitals. Also, you can find there some other successful case studies. Last question, looking ahead, what emerging trends and technologies in robotics do you anticipate will have a significant impact on the future of healthcare delivery? The question is for Ricardo.
Thank you, Marta, for the question. Actually, I think that I was thinking that the answer to this question was given by Gastone before, because the robotic application to be successful must be applied, inserted, must work inside an healthcare facility, an hospital that is already there, and you cannot extensively modify the environment in which the robot will be called to work. The hospital will have its corridors, its doors, stairs, several buildings maybe will be part of the facility, and the robot must adapt to them and not the other way around. Otherwise, it will be difficult for the application to be successful. And I think that to let the robotic application to adapt to the changing environment, because the environment is already there, cannot be changed in advance, but the environment will change during the years. So the application to be successful must adapt to an environment that changed during the lifetime of the application, given the investment, because robots are not actually cheap. And so I think that my idea is that for the application for the robotic application to adapt to an environment that changes, the robot must be aware of the environment in which it moves. So the technology that I think will be involved are actually all the technologies that will leverage artificial intelligence to let the robot be aware of the environment. For instance, in our application, what I think is that we will need to train the robot to see what happens around to have it move successfully into the environment. Just a few trivial example. It must go through a corridor which has doors. Is the door open or closed? Is it the door half, let's say, open halfway, so it's not completely closed and not completely open, and it has to interact with that, or how to find alternative paths to the if there are obstacles along the way, or what are the, for instance, in the case of sampling the handles of the door handles, what kind of handle is that? It's round. What is the shape? Is the handle of a panic door, a fire door, for instance? And the robot, and they will come in any different shape inside a real healthcare facility, and the robot has to adapt them if it has to perform the mission it has been assigned to. Thank you.
Yes, thank you. Thank you so much, Ricardo, for answering this question. Also, we are in ODIN project, we are analyzing also the impact of the different technologies that we are using. So we will also provide this outcome to all of you through our main website. So, well, thank you all for joining us today for this insightful mobile robotics webinar. I hope you found the information we shared with you valuable and gain new insights into the world of mobile robotics. Remember, innovation, learning, and collaboration are ongoing process, so don't hesitate to continue the conversation in our community of interest or reach out to our speakers. If you want to become a community member, please check our main website, click on this link. I really, really appreciate your participation today and look forward to seeing you at our future events, future webinars, that the next one will be focused more on artificial intelligence. Have a great day. Thank you so much for being here today. Thank you. Bye.
Bye-bye. Thank you very much. Bye.
Bye.
Bye-bye.
Bye. Bye.